Okay. So that's for the y-intercept. Okay. For the x-intercept, right, we want to know when y is 0. Okay? Well, that's where this is going to be, right? That's this point. I mean, what's the x coordinate of that point? In other words, where does the graph cross the x-axis? Well, as we saw already, we set y to be 0 and we solve for x. Essentially, you're setting the other variable to be 0. That's how I like to think of it. So for the x-intercept, you set y to be 0. For the y-intercept, you set x to be 0. And so we end up getting this to solve. And that's what I'm doing here, right? You know, just like before, from 1.1, we want to solve this equation. So we add 1 to both sides, right? Then we divide both sides by 2, right? Because you want to get x all alone, so we get a half. So a half is the x-intercept. In other words, this point here has coordinates. Let me see if I can write it out. Hopefully I'll be able, oh, it's not gonna come out right. I'll just say it. Let me just erase that. This point here, right, on the x-axis, where the graph touches the x-axis, you know, intersects it, this has coordinates a half, comma, 0. Here, this has this point here where it crosses the y-axis. Remember, the y-axis is always vertical. This has coordinates 0, comma, -1. Are there any questions about this? Okay, if there are no questions, then let's keep going. All right. So that's one example. Here's another, so that's what we have here. If we go back to the square, no, here's another example, excuse me. Okay. So here's another example, y equals 3x plus 4, okay? So here, right, what do we have? Well, we want to get the x and y intercept, right? I mean, the y intercept's a little bit easier. You can see from the graph that's going to be 4. But how would you get that algebraically? You set x to be 0. X is 0. And what does y have to be? Well, y is going to be 3 times 0 plus 4, which is 4. Remember, you set the other variable to be 0. So this point has coordinates 0, 4. The y-intercept is 4. For the x-intercept, okay, right, again, we want to know when y is 0. So we set y to be 0, and we solve for x. So what do? We solve for x. We get x all alone. This 4, we subtract 4 on both sides, right? Then we divide both sides by 3. And when you do that, these 3's cancel. You get -4/3. So this point here, right? Here, this is going to be -4/3. In other words, the coordinates of that point is -4/3, comma, 0. That's what we get there. Okay. Are there any questions about this one? Okay. So hopefully the idea of intercept is not that bad. I mean, in the past, I've given a question like this on an exam, and I would say find the X and Y intercept without using a graph. So let's look at our friend. Let's look at our friend, the square root of x. Y equals the square root of x. Well, looking at this graph, what are the X and Y intercepts? Well, notice that the only time the graph intersects the x-axis, right, and the y-axis is at the origin. Okay? So the only point, in other words, on the graph of the form something comma 0 is the origin. So the x-intercept is 0, and 0 is also the y-intercept. So in other words, because the graph only touches the x-axis at the origin, 0 is the x-intercept. Likewise, 0 is the only y-intercept. Otherwise, this graph never touches the x or y-axis. I mean, it turns out the graph keeps on going, keeps on getting bigger and bigger. That is, it keeps on rising. So, really hope that made sense. I hope it did. All right. Okay, any questions on this? Okay. Now we get to the parabola. This is actually the graph of this kind of this equation. Y equals ax squared plus bx plus c. Here, the right-hand side, as you can see, is a quadratic, which is a polynomial of degree 2. We have ax squared plus bx plus c. Here, a, b, and c are numbers, but a cannot be 0. The graph of this is a parabola. Okay? No matter what a, b, and c are, as long as a is not 0, the graph is a parabola. I know you might be thinking, wait a minute, that's going to be lots of different graphs, right? Well, it turns out they all look like the graph of y equals x squared, you'll see shortly. So they all look very similar to each other. I mean, obviously what A, B, and C are will determine the exact graph, but they all look very similar to the graph of y equals x squared. And we can also find x and y intercepts. I mean, for the examples we just saw, we only dealt with lines, essentially, although just before we had this y equals the square root of x. But to get the x and y intercepts here, we're going to use what we saw in 1.2. You know, in particular, for the x-intercepts, right, we're going to set y to be 0 and find out what x is. For the y-intercepts, right, that's actually a little bit easier. You just set x to be 0. You're actually going to get this constant term c, as you can see. Okay. So that's what we have here. And of course, for this one, you could use the quadratic formula, or you can use factor. I mean, sometimes factoring is a little bit easier, but you know, that's different, I guess. Different story, I guess. So for instance, what does the graph of x squared, y equals x squared look like? Well, so again, here, I just chose x values kind of randomly, right? For each x, I put it into the I put it into the equation to get the corresponding y value. So we have y equals minus 2 squared, right? Notice not just 2 is being squared, the negative is as well. We're going to get a non-negative number here, right? With the negatives, you have to be careful. But you get minus 2 squared, which is 4. So we get this. But here we have -1 squared, and that's just 1. So this is also on the graph. I labeled A, B, C, and so on, just to make it a little bit easier to see. So -2, 4, that's over here. -1, 1 is here. And 0, right? 0 squared is 0. See? When x is 1, we plug it in. We get y is 1. So this is on the graph. And finally, when x is 2, 2 squared is equal to 4. That's also on the graph. Okay. Notice also, this is what the graph of y equals x squared is. This is a parabola. Okay. You know, I connected the dots, so to say, using a smooth curve. But any parabola is going to look something like this. You know, it might be shifted horizontally to the left or right. It might be, how do I say this? It might be turned upside down. You know, it might be compressed or stretched out horizontally. It's going to look something like this, though, a parabola. Notice also here, it's only intersecting the graph, excuse me, the x-axis and the y-axis at 0, the origin, right? Right? The only time it touches the x-axis is at the origin. So because of that, the x-intercept is 0 and the y-intercept is 0. Or if you want, you can think of it this way. This might be easier. The only point on the graph where a coordinate is 0 is the origin. So the x-coordinate is 0, right? And the y-coordinate is 0 only at the origin. So the x and y intercepts are 0.